So let's talk about AI. We're going to dive into something pretty new, a kind of AI that's built from the ground up with this really radical idea. What if you could actually, trust it? It's called NeuroSymbolic AI, and it's a big deal.
But let's just start with this one. Really simple question. Imagine an AI makes a huge decision. I'm talking about your health, your money, your safety, but it can't tell you why. It just gives you an answer. Could you really, truly trust that?
And here's the thing, this isn't some far-off sci-fi scenario. This is happening right now, every single day, in fields like medicine, banking, even the cars we're starting to see on the road. AI is making those kinds of calls. It's already shaping our lives, often behind the scenes.
Okay, so Section 1, AI's black box problem. To really get why NeuroSymbolic AI is such a game changer, we've got to first tackle the huge issue it's designed to fix. It's what everyone in the field calls the black box problem.
All right, so what is this black box? Well, think about a lot of today's most powerful AIs, the ones built on deep learning. They are absolutely brilliant at finding patterns, but, and this is a huge but, they're completely opaque. You can put data in, you get an answer out. But what happens in the middle? It's a total mystery. And that's a problem, right? Because it means they can have all sorts of hidden biases they picked up from the data, and they give you zero, and I mean zero, guarantees that they're going to be safe or fair.
And look, this is getting more urgent by the day, because AI isn't just sitting still. We've already nailed what's called artificial narrow intelligence, or ANI. AI that's good at one specific thing. But we're pushing hard towards AGI, artificial general intelligence, and beyond that, maybe even superintelligence. Now imagine an AI that powerful that we still can't understand or control. That's a huge, huge risk. We're basically building this incredible engine without knowing how to build the brakes.
So, how do we fix this? Researchers think the answer might be a team-up. Let's dive into Section 2, a tale of two AIs. To get a handle on this, just picture two different kinds of AI. One is like an intuitive artist, and the other is a super logical detective.
Okay, so first up is neural AI. This is our artist. It learns by just looking at millions and millions of things, like pictures or sounds. It gets amazing at spotting really subtle patterns in all that messy, real-world data. The catch? Just like a true artist, it works on a gut feeling. It can't explain how it does what it does. That's our black box. Then you've got symbolic AI, our detective. This one is all about logic. It follows a strict set of rules, step by step. It can tell you its reasoning for everything, crystal clear. But it's super rigid. Throw some chaotic, real-world data at it, and it just gets stuck.
So you see the problem, right? We've got these two very different, powerful but flawed approaches. The artist is a genius at perception, and the detective is a master of pure logic. It's almost like they're two halves of a whole. Each one has exactly what the other needs. So what if you could get them to work together?
And boom, that's where we get to Section 3, the NeuroSymbolic solution. This is the hero of our story. It's all about taking the best of both worlds and putting them together. So, what is it exactly? NeuroSymbolic AI, or NeSy for short, is basically that team-up we were just talking about. It combines the artist's knack for pattern recognition with the detective's step-by-step logic. The goal here isn't just for the AI to see what's going on, but to actually reason about it in a way that we humans can understand. Okay, so how does this dynamic duo actually work in practice? Let's walk through it. First, the artist, that's our neural network, takes a look at the messy data, say a medical scan. It spots a little clue, a faint pattern that a human might miss. Then it hands that clue over to the detective, the symbolic system. The detective takes that clue and starts building a logical case, using a set of hard-coded rules, like official medical guidelines. And what you get at the end isn't just an answer, it's an answer with the full explanation attached. You can see the work. All right, let's move on to Section 4, which is really the heart of the matter, making AI responsible. So how does this team up actually create an AI we can trust? Well, the magic of NeSy is that it doesn't just cross its fingers and hope for the best when it comes to things like fairness and safety. It actually bakes those ideas right into the AI's core design. Okay, first big problem, lack of transparency. We keep talking about this black box issue, so how does NeSy crack it open? Simple, interpretable reasoning. NeSy is built from the ground up to explain itself. It produces these clear, logic-based reasons for every single thing it does. It's like leaving a trail of breadcrumbs that a person can actually follow. You get the why, the statistical hint from the neural network,
combined with the clear because from the logical rules.
Next up, another massive hurdle for AI: fairness and bias. How do you stop an AI from being unfair?
NeSy's solution is called constraint encoding. It's totally proactive. Instead of just hoping the AI learns to be fair from the data, you literally write the rules of fairness into its code. You can encode ethical principles or even specific mathematical definitions of fairness as hard limits. They become guardrails the AI physically cannot cross.
And number 3, the big one, especially when things are moving, safety and reliability. And for this, NeSy uses something really cool called formal verification. It's basically a mathematical guarantee of safety. You can take something like the laws of physics and hard-code them as rules for, say, a self-driving car. Then you can literally prove, with math, that the AI will never, ever violate those rules. It's like a safety net. And it can also create backup plans, logical if-this-then-that scenarios, for when it runs into something totally new.
Okay, so this sounds fantastic on paper, but is it actually being used? Let's get into Section 5, NeSy in the real world. Where is this technology making a difference right now?
Unsurprisingly, it's popping up in the places where trust matters most. Take healthcare, for example. It's being used to make diagnostic suggestions that doctors can actually question and understand. Or in finance, it can help make loan decisions that are fully auditable so you can check if they're fair. And of course, in self-driving cars and other autonomous systems, it's all about baking in those safety rules we were just talking about.
Think about a self-driving car for a second. Instead of just slowing down, imagine it could tell you why. Hey, I'm hitting the brakes because my neural network spotted something that looks like a person and my symbolic rules say you always yield to pedestrians. It's not just doing something, it's explaining its reasoning. That single word, because, that's everything. That's the foundation of trust.
And this isn't just for things that move. Take the legal world. There are NeuSy systems in development that can read through super complex contracts. The neural artist part understands the tricky legal language, and the symbolic detective part checks everything against a massive set of rules, like all the regulations in the big EU AI Act. It's a pretty powerful combination.
So if you take away one thing from all this, let it be this. With NeuroSymbolic AI, responsibility isn't just some feature you try to bolt on at the end. It's not an afterthought. It is baked right into the core design of the AI, right from the very beginning.
Which kind of leaves us with one big final question to think about. As AI gets more and more powerful, maybe the goal isn't just to make it smarter. Maybe the real challenge is to make it wise. And by teaming up that incredible power of perception with the clear, cold logic of reason, NeuroSymbolic AI, well, it might just be our best shot at getting there.